Okay, welcome to Max-Min word problems. These are more physical word problems and less business word problems, whereas the last section was more business word problems. So these are more physical. We'll also introduce a new method, so we're going to do a sign chart. We're going to do, I think all of these are sign charts, and none of these are tables and then we'll do second derivative test. All right, so let's go ahead and get started. So the first one is we have the profit per acre for orange trees, and we're given that this is the profit. Okay, so we know that P of X equals X times 130 minus X. So that is 130X minus X squared. And we want to maximize that. So what do? We take the derivative. So we find P prime of X. So that's 130 minus 2X. Set it equal to 0. Sorry, I forgot where I was. And we solve for X. Now, we cannot just assume that that is our answer. We need to either make a table, which means that it has to be bounded, that we have to know that there's an upper bound for that and a lower bound for that, or we have to make a sign chart. So there's no interval, so we don't know an upper bound and a lower bound, so let's make a sign chart. So sign chart, because there's no interval. Okay, so what does that mean? That means that we have 65, so we pick a value over here, so x equals 0, and a value over here, so x equals 70, and we plug them into the derivative. So if I put 0 in here, I'm going to get 30, so that's positive. If I put 70 in here, I'm going to get 140, so that's negative. I'm going to get negative 140, so that means it goes up and then down, so it's a max. All right. Now it wants to know how many trees per acre will maximize the profit. So it wants to know how many trees. I can also find the maximum profit by putting the 65 back into the profit. And so I get 130 times 65 minus 65 squared, and I get 4,225. So they need to plant 65 trees per acre to yield a profit of $4,225. Okay? That's it. So let's go on to the next one. The next one again gives us our function. Okay? We have the output for an 8-hour shift is given by this function, and we want to know how many hourly units. So 1 unit is an 8-hour shift. So how many 8-hour shifts we need to maximize our output. All right, so we find the derivative. So y prime equals 102 plus t minus 2t squared minus 3t squared. This is why I have it worked out next to me. So I'm going to set this equal to 0, so that's minus 3t squared plus t plus 102. Now I need to factor that, so that's 306 because to factor that, you multiply, I'm going to pull out a negative. 0 equals negative 1 times 3t squared minus t minus 102. To factor this, you're going to multiply the 3 times the 102, and you want factors of that. And you make a factor tree of 306, and what you come up with is that it's 18 times 17. And so now I'm going to go through the whole how to factor this. So that's 0 equals negative 1 times 3t squared minus 18t plus 17t minus 102. Okay, and you're going to group the first two together and the last two together. So that's 0 equals negative 1 times, pull out the 3, so that's t minus 6, plus pull out the 17, pull out the 3t, so that's 17, t minus 6, then you pull out the t minus 6, so you get negative 1 times t minus 6 times 3t plus 17. So you get t equals 6 and negative 17 thirds. Again, we don't have, so no interval. Actually, this says that t is between 0 and 8, but that's because t is an 8-hour shift. It's not that it's not that t is checking something out. I guess you could say that it is between. So we could do a table here that t is between 0 and 8, but 17 thirds is not in that. So let's look at a table. So table, and so we have 0 and 8, and so we have 0, so we have t, and then we have y, and so we have 0, 6, and 8. And so if we put 0 in, we get 0. If we put 6 in, we get 102 times 6 plus 1/2 times 36 minus sorry, I'm doing this because this is not how I had done it, but you can do it this way. 216. So, change calculators. Okay, so that's 102 times 6 minus 102 times 6 plus 0.5 times 36 minus 216. And so this equals 414. And you have 102 times 8 plus 1/2 times 64 minus 8 cubed is 512. So that's 102 times 8 minus 0.5 times 64. I did minus again. and that's 336. So this is my min, and this is my max. Okay? And so what that tells us is the maximum is 6 hours, and it's 414. So the maximum hourly output is 414 units per hour when 6 hourly units are worked. Okay? All right. So now let's look at number 3. So number 3, it gives you, suppose that the demand equation is given by X, and the consumer expenditure is found by finding P times X. So what is the market price expenditure the greatest? So it's just asking you to find the max. Okay, so you're going to find E prime of X to be 10,000 minus 500 P, E prime of P, set it equal to 0. So then P equals 20. And since there's no interval, then we do a sign chart. If we put in that in 0, we get a positive. If we put in 30, we get a negative. So we're going up, then down. So this is our max. We find our market expenditure of 20 to yield a value of $100,000. So then when the market price is 20, the expenditure will be the greatest of $100,000. Right? Okay. The next question is where you're going to start having to come up with the formulas on your own, and they're physical questions, and they're area questions, and they're like, well, why do I have to do these? Well, they're actually ones that you could actually come up with. So it's a rectangular field. You want to put a fence on it. So you have a field. You want to put a fence on it. This one says that you have a river right here. Okay, what if you had a house right there? So out here, every house out, and I say out here because I'm from East Tennessee, but every house out here in Texas has a house around it, has a fence around the backyard. So you want to put a fence around your backyard. How much will it cost you, and how much fence do you need to have? If you know that this area equals 80,000 square feet, and you know that this is $40 per foot, and that this is $10 per foot, how much is it going to cost you? And this is a real live question that any homeowner is going to have to know how to do. Okay? So, and it gets more complicated for a homeowner than this. This is just the basics. Okay? So, what you're going to want to do is I always let X be the horizontal distance and Y be the vertical distance. Because when you draw an XY chart, this is X and this is Y. And if you keep them that way when you set up these word problems, then it will always keep them straight in your head. It should not matter, but it will always keep it straight in your head. If I give you something like this on a test, I will give you the picture and I will label X and Y so that everybody has the same question. All right. So now let's set up the word problems now that we have the picture drawn. And by the way, the picture is part of your work. You get points for having the picture. Okay? So, area equals X times Y, which is 80,000 feet. Then we know that Y equals 80,000 divided by X, so that's 80,000 X to the negative 1. Okay, we're going to need all that information. All right, cost. The cost is going to be cost equals 10Y plus 40X plus 10Y, which is 20Y plus 40X. Yes, I know I could go straight to the other, but I do it the way I do it for a reason, okay? So if you can skip steps, yes, you can skip steps, okay? Now, I'm going to put my Y down into X. Now I'm going to write C of X. So my cost in terms of X is going to be 20 times the 80 X to the negative 1 plus 40 X. Now I can put that little X there because now I only have one variable. So that's going to give me 1, 6, 1, 2, 3, 4, 5 X to the negative 1 plus 40 X. Okay, so now I have all my original functions. This is the function I want to take the derivative of. So this is C of X. This is the function I want to minimize. I want to find the min of that function right there. And at this point right here, X equals to 0 is a critical point. It's the derivative. I'm setting the derivative equal to 0. Two, 3, 4, 5 over X squared equals 40. My LCD is X squared, so I multiply both sides by X squared, so I get 16 equals 40 X squared, divide both sides by 40, so I get 4 with 4 zeros, 1, 2, 3, 4 equals X squared. Take the square root of both sides, so I get plus or minus 200 equals x. Oh, well, we know the answer has to be the positive one because we're talking about a... No, you have to do a sign chart. You have to do a sign chart. If you don't do a sign chart, guess what? You will lose points. So here is negative 200. Here is positive 200. Because I could give you a question where negative 200 comes out to be the correct answer, even though it doesn't make sense. And I have done that before. And you have to try 0 because 0 is a critical point. 0 is a critical point. So that's 0. So we have to try x equals negative 1. We have to try x equals 1. And we have to try x equals 300. Okay? So what we get is that we go down. We get a negative, a positive, and a negative. So we go up, up, and down. So this is our max. Okay? All right? So what that tells us is that if x equals 200, then we plug it into y equals 80,000 over 200. So that means y equals 400. Our cost is going to be 20 times 400 plus 40 times 20 times 200, sorry, equals 16. Okay, so now we know all our information, so we can write our sentence. The minimum cost is $16,000 when the dimensions of the field are 200 feet by 400 feet. Okay? Now, when I write a test, I am not opposed to making negative answers even though they don't make sense. I'm also not opposed to making fraction answers even though they don't make sense, just to make you do the sign chart, okay? So make sure you're doing the sign chart, all right? Okay, we're done. All right, so now, hello, post. I've gotten into something and I don't know what. All right, done. All right, now let's go on to the next one. Now we're going to talk about the second derivative test. So first off, there's a typo. This should be less than, not greater than. So what you're doing with the second derivative test is you're checking whether or not the first derivative is a max or a min. And what that tells you is it tells you whether the function is a max or a min. Okay? If the second derivative test is greater than 0, then the function is a minimum. Notice that I said if the second derivative is greater than 0, then the function's a min. It's opposite of what you would think. You would think, oh, well, if it's greater than 0, it should be a max. No. If the second derivative is greater than 0, then the function is a min. if the second derivative is less than 0, the function's a max. All right? Now, this is how we're going to answer the next two questions. All right, we're going to use the second derivative test. Okay? So, again, we have to come up with the equations. All right, so the first one, we have a rectangular fence, a rectangular field. We're going to split it in half with the fence down the middle. This area is 1,200 feet squared, and this area is 1,200 feet squared. Okay? We're going to call this X, this X, this is X, this is X, this is Y. Hello, that doesn't look like a Y. This is Y, this is Y, this is Y. All right? So our area equals X times Y equals 1,200. Then we know that Y equals 1,200 divided by X equals 1,200 X to the negative 1. All right? This also tells us that X equals 0 is a critical point. All right? Now let's talk about how to find our fence. So our fencing, so we just want to know how much fencing we need. I'm going to start right here. And I'm going to go this way. So we need Y plus X, so here to here to here, plus Y plus X. So I've gone around that whole first square. So I've gone around here. Now I'm going to go, now I'm here. I'm not going to go back over the X again. Plus X plus, so here, Y plus X. Then here, then here. Okay? So that's 4X plus 3Y. All right? Now I'm going to put Y into there. So F of X is going to be 4X plus 3 times 1,200 X to the negative 1. Okay, so I have that. So that is my function that I want to minimize. So I want to minimize this. Okay, so I'm going to find f prime. All right, set it equal to 0. All right, pull the 3,600 to the other side. Multiply both sides by x squared. Divide by 4. So x equals plus or minus 30. Okay. Right? Now, I want to find the second derivative. So if I find the second derivative, right, then that gives me 7,200 x to the negative 3. Right, so that's 72 over x cubed. So if I find now, and I'm going to just plug in, remember I've got to have 0, so I need to try it at, so I want to try this at x equals 0, x equals negative 30, and x equals 30. So I want the second derivative at 0 is undefined. So I know nothing. It tells me nothing, it means nothing. Okay? So then I find f double prime of negative 30, and all I care about is the sign. Okay? So I have a positive value over a negative value, right? Because if I have a 7,200 in the top and a negative 30 cubed in the bottom, that's negative. So this thing is less than 0. So is that a max or a min? Well, it's opposite of what I think it is. So less than, you would think it's a minimum, so this is the max. F double prime of 30 is a positive value over a positive value, so that's greater than 0, so that's my minimum. All right? So now what I need to do is I need to find my y value. So if y equals 1200 divided by 30, so that's 40. And I need to find my fence so my fence is 4 times 30 plus 3 times 40, so that's going to be 240 feet. So then the minimum amount of fence is 240 feet when the dimensions of each field of each lot is 40 feet by 30 feet. Okay? That's it. All right, we have one more example. And this example kind of talks you through the second derivative test, but let's get the equation set up. Getting the equation set up is the hardest part. Usually once you get the equation set up, you're good to go. All right, so let's get the equation set up. So we're going to have a rectangular area, and we're going to split it into thirds. All right, this whole length is x, and this whole length is x, and each of these are y. All right, the inside portions are $20, and the outsides are all 10. Okay? And it tells us that. That's it. We want to maximize, so we want to maximize the area, which is xy. We are given $1,000 to spend on the fence. So that is 10x plus 10y plus 20y plus 20y plus 10y plus 10x. Now let's combine things. So that's 1,000 plus 1,000 equals 20x plus 60y. I'm going to divide everything through by 10. So that's 100 equals 2x plus 6y. I'm going to now solve for x. Okay, so solve for x, because this tells me that I want it in terms of y. So I want to solve for x. All right, so I have 100 minus 6y equals 2x. Divide everything by 2. So that's 50 minus 3y equals x. So that tells me that a of y, now I'm putting it into the area, equals 50 minus 3y times y equals 50y minus 3y squared. So that's the answer to part A. Part B says find a double prime. So a prime is going to be 50y minus 6y squared. Right, 6y. That shouldn't have a y right there. Now I'm okay. And a double prime should be minus 6. Okay? And part C then says to maximize. All right, so now I'm going to maximize. So I'm going to go back to the first derivative and set it equal to 0. So I have 50 minus 6y. So then I have 6y equals 50. So y equals 50 over 6, which is 25 thirds. So now what I'm going to do is I'm going to scroll up just a little bit. Is I'm going to use the second derivative, so a double prime, and I'm going to plug 25 thirds into that second derivative, which is less than 0. Notice this is less than 0 for any value I found, so that means that it is a max. Okay, so if I found 25 thirds for y, so I have 50 minus 3 times 25 thirds. That's my x. So then, now I'm looking for x. So I have 25 as x. Okay? So the dimensions of the field are 25 feet by 25 thirds feet. And I would leave it as 25 thirds. The answer contains a fraction. Okay? And that's it. All right? Please email me if you have any questions.